Alrighty, welcome back to my channel, guys. Recently, I've been playing around with the Docker API in Go, and honestly, it's quite peculiar, and it was a little bit frustrating and also fun to work with it. So I wanted to make this video just to explore what we can do with an API client, like a Docker API client in Go. So today I'll show you how to can build this very small application in Go, where we will basically take a folder that has a Dockerfile, make that into an archive, basically just build the Docker image from there, and then spin it up in a container. So if I run this application now, you'll see that I'm building this application from a folder here that I'll show you now. Has a sample Docker file. Basically, it has an Nginx application, and then you can see here that we have streamed back the result of the Docker build, and then basically just literally ran this extremely simple Docker file. So we created the container, and we also ran it. So now if I curl 2000, you can see now that I have this running on the port 2000 from the container, and it's also mapped to port 3000 from my host, so I can curl 3000 right away. I want to show you also what we have inside there. So you can basically see here we have this folder called sample Docker app, and it has nothing much really there. It has a Docker file, Nginx config, and index.html, and that's what we just ran. Cool. So I will clean this up real quick, and obviously you can see here on the right hand side, this is orb stack. Orb stack is kind of like what I use to run the Docker client. You can use anything to run, basically depending on what OS you have running. Orb stack has been working very well for me, so I haven't replaced it in years now. So yeah, you can see obviously after I ran this, we have that container here, and then we have the port mapping like we discussed, and then we have that image that we built there, which is the simple app latest image, which is built based on Nginx Alpine. Cool, let me clean this up and then we can get started. All right, so I've cleaned up all the images and the container that we just spun. And then I also cleaned up all the code. So let's get started. So the first thing you need to do is basically spin up an API client that comes from Docker. Now, the Docker packages in Go have been really going through some stuff. So basically, usually you would get that from GitHub /docker/docker as in a go get command, basically like this, go get something like that. You don't want to do this now because now they have this Moby project, which is supposed to replace everything with Docker. You will see some of my imports here automatically get handed over by the LSP. Some of them are owned from Docker and some of them are coming from Moby. It's quite frustrating and confusing. You can check out the post where I go in more details. But basically, the first step we need to do is just basically make an API client. And that API client, which basically will come from, what am I doing? Sorry, I write too many languages. So basically, let's do this. Client, yep, if I can type today. So I get client from Moby, as you can see here, and then client.new, and then I'm simply just gonna give it, we don't need any specific options here, so I'm just gonna pass from environment. So basically, get the options from environment, and that will allow you to control things with environment variables if you need to. In this case, we're not doing anything crazy really. We're just spinning up a new client. Obviously, you want to check all the errors. I'm simply skipping over the errors in the video to make things a little bit shorter. So now I have my API client. The first thing I need to do actually before I use this API client is that I have to package my folder into a tar, or basically like an archive that I can pass to the Docker API, so that the Docker API knows how to work with it. So basically, let's just call that package Docker folder into tar. So let's do that. The way we are going to do that, like this. We are going to use the archive tar package. So that will come back from archive. Basically from archive, again, coming from Moby, archive.tar, that's right, archive.tar, we're going to use this function. And then here we need to pass the folder that I'm trying to basically compress. And then here we need to pass what kind of compression I want. I honestly don't really care as much about what kind of compression. So in this case, I'm just going to do compression No, just compression none actually. So I'm just gonna not gonna compress this at all. Cool. So now what I've done here is that I've got this response here, which is basically an IO reader that I can use to pass into the Docker API to say, hey, this is where my Docker file is, and this is the folder that I'm trying to spin, basically build an image based on it. So this is what I'm gonna do next. So basically build an image with API client now using that tar. So that's kind of the second step that we need to do. So let's do that. So what we need to do here is let's just call this build response that will come back and an error that we are going to ignore, and then let's just go like, oops, not this one. Sorry, let's do that again. Let's do it like that, and then API client dot. Let's just call this build. No. I think it's like image build. Yes, image build. And then that's why we have the context. We just pass the context. And again, here, this is the build context. If you recall, like it depends how much you have experience with Docker, but you need to pass this build context. Like it's basically the dot that you do in Docker build dot. That's the context that you're trying to pass through. And obviously here you have to pass it in an archive. So you can imagine that we have packaged that folder into an archive for the Docker API. So in this case, I'm just simply going to pass tar. And then here, the image build options is basically, I need to tell Docker what kind of image I'm building. So in this case, we actually need to pass a couple of things here. The most important thing is the tag. So I just need to tag this, and then I'm going to tag this with a name. Basically, in this tag, I'm going to call this simple app latest. So this is the tag. So this part here is kind of akin to you basically running a Docker build command, right? So Docker build dot, and then we are tagging it with a specific thing. So this is basically building that image. Another thing I forgot is actually to close this bad boy. So tar close here again, because this is an IO reader. The same thing we're going to do with the build response as well. So build response, build response. I think it will come with a body that we have to close ourselves. So we just defer to close that so we don't leave anything open. Cool. Now at this point, I'm literally running the build command. So this is when you kind of like run Docker build from your CLI, but I want to see the result. Seeing the result has been more challenging than you would think, really, to be honest. And the reason is because the way the Docker API works. Hold on. The way the Docker CLI works is that it's basically takes over your terminal and sends you over these kind of like progress bars, and then it will show you these kind of compact ways in downloading and so on. So it's kind of literally taking over your terminal. So that's why to do that, we actually have a package from Moby to do nothing but that. So if you were to experience this on your own, or experiment on your own, you will see that the Docker API client is just going to send you JSONs to show the progress. But those JSONs are not what you and me are kind of expecting when you run a Docker build command. What we are expecting is kind of like that progress that we see when we run the Docker build from the CLI. And that's what we are trying to convert now. We are trying to convert that build response into that, basically the stream that you usually get. To do that, we're going to use the JSON message. Again, remember, the API response is just basically a bunch of JSONs, and JSON message is a package that we can use to basically display JSON message stream. And that's the whole point. So basically, we have the raw JSON messages coming from the API, and then we are going to stream it into the OS std out, basically. Now, where is this gonna come from? Where is the reader? The reader in this case is basically the build response.body without closing, obviously. So that's the build response.body. And then where are we streaming out this stuff to? We are streaming that out to std out. Now, there's a couple of things here that are important, which is basically what kind of a terminal is this? And the reason is because this function is really smart. If it kind of like knows what you're passing into it, or where you actually want to, kind of like stream this stuff. If it's being streamed into a file, it's going to give you a different format. If it's being streamed into a terminal, like what we're doing here, it's going to give you that interactive stuff. Now, I'm going to do this the simple way first. I'm going to just pass one here, which says like you are, this is the type of terminal that you're working with. It's a TTY terminal. In this case, it will go into that mode where it just kind of like takes over the whole thing. And is it a terminal? Again, I'm just going to make this simple and say that it's true. We don't need this aux callback, so I'm just going to pass null. I'm going to pass nil here. Null. I'm going to pass nil here. Cool. Now, this is sufficient for what we're trying to do here, because I know that OS, the std out is basically a terminal that I'm trying to take over. I'm going to show you quickly what you can do if you don't know. So sometimes, say for example, you are trying to stream a build result that is running on your VPS or on the server, and you're trying to stream that back, then that can be a little bit different. So you want to pass a proper different kind of like different values into here, depending on what kind of reader OS std out is. If it's a file, it's going to be something else, and so on. To do this, there is another package called term. Again, this is all from Moby. So you can go get fd info, and this is the interface that goes in, which is basically the os.std out here. So what this will do is that it will give you the values of those two values that we have put there, and then we can do this ftd term and is term, and that's basically what comes back. And then we can not pipe, but just basically put these values in here. So fd.term, and then this one here is terminal. Again, remember, this is not needed per se, but I'm just doing it to show you that you can do more stuff, basically. If you think about it, you can do a lot more stuff. So this can be a response coming back from the API, for example, if you want to do, or it can be a file reader. It can be whatever, really. So that's why this function exists, to allow this function to do a lot more crazy stuff depending on what it's actually trying to output in. Fantastic. I know it's been a long time, but again, like I said, the Docker API is just full of gems. But yeah, it's really compact and really clever. So yeah, cool. So now we have built the image. And at this point in time, we have already streamed back into the terminal those build progress bars and everything. Now, what we want to do after this is basically create a container, get the IP of that container, and spin it up. So let's do that. So let's just say create a response here, and then there's an error that we are going to ignore, and then API client dot, I believe this is container create. Thank you, container create. Again, we're passing the context here, and this is the option. Now, the option here is going to be a little bit interesting. So remember, when you spin up a container, basically you want to pass multiple things. The first thing you need to pass is the container config. So let's just do that. So let's do that. This is simple. This is just basically the container config here. So yeah, again, this is all types coming from the Moby package. So container.config. So this is actually quite simple. So container.config. And in this case, I just need to tell it, okay, what kind of like image am I basically going to run here? And in this case, I'm just running basically the image, which is simple-app latest, which is the one that we have built running this command. So in this case, it's just simple. I'm just saying, hey, spin up this container. And the first thing you need to provide is like which image you need to pass in. So that's good, but we still need a lot more than this. So basically, we need some things for the host config. So remember that basically this Dockerfile here has an expose 3000. So that means what this means is that basically the Nginx inside is basically running on 3000 and it's exposing that port to the outside world. What I need to do here, oops, wow, really? I can edit from here. I did not know that. Okay, can I exit this? Oh, wow. Okay, cool. I don't know if I screwed up the Dockerfile now. Okay, I did not. Cool. Anyway, so what I need to do now is basically have this mapping of ports, and that is a bit more involved, let's just say. So what I need to do here is basically have this port mapping here. Oops, let's just say port bindings. And the port bindings here is going to be a map of ports between, remember, the container to the host. So let's do that, but let's do it step by step. So the first thing I need to do here is basically do this, which is going to be network port port binding here. Yes, okay, cool. And then I need to kind of like create this one by one. So I'll do that a bit slowly, so we can see exactly what we're doing here. So the first thing I have to do here is basically initialize a container port, container port, right? So I'm initializing a container port, and in this case, I'm going to use the network type from Moby, and I'm going to say here there is a port, and then I know that the container port will run a 3000 TCP, because that's the port that I have there. Yeah, so in this case, I'm not going to use port. I'm just going to parse this port into a network port here, and then I believe this one was going to return a port and an error. What am I doing? So close this. Yes, fantastic. And then again, as usual, we are just going to ignore that error. So let's just do that. Cool. So I just used the parse port, which is coming from the network package. Network package is coming from Moby, like we discussed. And then I'm parsing this port, which is 3000 TCP, to be the container port. Fantastic. The second thing I need to do is I need to basically say this port on the container has to map out to this port on my host, but that host needs to have an address. So let's do that. So let's just say this is the local address here, and this local address, we are going to get that from netIP, which is basically in the standard library. I'm going to say this is a must parse address. So I'm basically saying, this is obviously not something you would usually do, but because this is just for prototyping, so I'm going to say this is my the IP address of my local, and it must parse. So I'm ignoring the error here. This will definitely work. This is exactly what I'm saying to the library here. Finally, I need to do local port bindings, which is basically going to be the list that we're going to pass down there on line 30, basically here. So I need to initialize this on line 43. So I was just going to say that this is going to be network.port binding. Yep, a list of network port bindings. And in this case, what I will do is I'm going to say, like, we have a host IP, and this is taking the type of net IP address. That's why we did this, what we did earlier. So this will be a local address. Let me just fix that quickly. Yes, cool. And then the port here, the host port, is simply going to be 3000. Amazing. So that will just say, I have this container port, and then I have this local port binding that is going to bind to 3000 on my local host, basically, which is 4 zeros. So if I go back here, all I have to do now to make this cleaner. Okay. Right. So now, actually, this was a mistake on my behalf. So what I have to do here is that I need to pass here a port map. So yes, this is a port map, and that port map basically maps two ports to each other, which is what we're trying to do here. So a container port is going to map out to the local port bindings, and then that will be the end of it. So basically, this is how you do it. So let me get this over again. So basically, what we're doing here is that we are doing a port binding on the host config, and then basically we are binding a port map, and that port map is binding that container port, which is 3000, and it's binding that into the local port, which is also 3000 on the address of 4 zeros. I hope that makes sense. Cool. So we got this create response here. And now what I will do is that I'm going to get the create response.id, and this is the ID that we are going to use to basically start that container. So what I'll do here, I'm going to say start response here and an error that we are going to ignore. And then finally, I'm going to say API client.container start. Yes, container start, exactly. I'm passing in my background context. And then that's the container ID that I was talking about here. So we're going to go like container response ID. That's the one that came from there. And in this case, I don't really have any options to pass there. So I'm not going to be fussed about it. And then I'm actually going to treat this error in a better way. So I'm just going to say, if the start error does not equal nil, this is the only error I am going to actually handle, and then just call this start error, and then I don't actually need this anymore, so I'm just going to ignore it. I'm just looking at there. Cool. And this should be everything that we need to do. So you can imagine that that the Docker CLI is actually doing a lot of things for you in the background. So the first thing we had to do was basically package that folder into a tar that we pass into the API. That's done. And then we use that to build an image. And after that, we got the image. And after that, we got the build response. And then we stream that into the terminal to show those beautiful kind of like progress bars that we are used to. And then after this, we need to create a container. And this was a bit involved just because we need to map out these host configs. So we need to do a network port map, which is basically port mapping between those two things, the container and our host. And the way we do that is basically a bit more involved. So we need to specify what's the container on the port, and also what's the host port, and then get that binding done, and then finally start that container after we've created it. So let me test this by going back here, clearing this, and go run main.go. Have a look on this side as well. You'll see the container come up live, and then the image come up live as here. Let's run this. So you can see this is what I talked about earlier. We are pulling, and then these interactive results of the build is what happened. And then basically we've downloaded it, we have ran it, we got the IP, the ID of that container, and then we basically just ran that container. So if I go back here, I'll see that container running, and if I curl it, you can see that it's working. That's it. A little bit long video this time, but I just wanted to give you a taste of what it is to work with the Docker API in Go. There is a lot more crazy stuff that you can do. One of the most craziest thing that I've done recently is basically have this client not run on your local. Yes. So in other words, this client doesn't really have to connect to your local Docker. It can actually connect to the Docker running on your VPS. And then from there, you can stop images, you can stop containers, build images, do whatever you want. And it's really, really cool. So that's something that's kind of like going to be advanced level, or something that you can actually think about doing to automate some work on your VPS, which obviously what I do with Sidekick. But yeah, it's something worth mentioning. Thank you for watching. If you like this video, let me know. And I'll see you in the next one. Cheers. Bye.